Good morning, everyone. Welcome to Statistical Debate 2, the second event in the debate series sponsored by National Institute of Statistical Sciences. The topic of today's debate is teaching statistics versus data science in grades K-12. I am Kyung Liu from Department of Mathematical Sciences in Bentley University. On behalf of NIST, I'm very excited to moderate this event. This event will be held in a debate type of format. The participants have been given selected questions ahead of time, so they have had a chance to think about them. This session is intended to be a presentation, but it is not intended to be a presentation, but instead a chance to provide some give and take between the participants. We hope that in this way, we can help to provide everyone with a full review of the main aspects of the topic. Each participant will get a chance to be the first to address the question, as well as a chance to respond. After all of the pre-select questions have been addressed, the session will become a Q&A session. If any of the attendees has a question they would like to be addressed by the participants, please make sure to type these questions into the Zoom Q&A tool. In 2005, ASA released the Guidelines for Assessment and Instruction in Statistics Education, a pre-K-12 curriculum framework, GAISE-1. A slight revision of the document followed in 2007. In 2020, GAISE-2 report, providing a framework for statistics and data science education, was published by ASA. What are the challenges and changes that have happened to teaching stats and data science in grades K-12 over the years? What has worked? How do we move forward? These are just some of the questions we're likely pondering in our quest to best equip our students with the data skills they need. We hope the debate will facilitate our discussion about some of the most relevant and urgent questions that are facing statistics and data science education in grades K-12 today. All three participants in today's debate bring extensive experience in statistics education. Firstly, all three are members of the writing team of the GAISE Pre-K-12 Guidelines for Assessment and Instruction in Statistics Education 2 report. Dr. Bargigliotti and Dr. Franklin serving as co-chairs of this committee. In particular, Dr. Anna Bargigliotti is professor of mathematics, is the Seaver College of Science and Engineering and Loyola Marymount University. She received her PhD at the University of California, Irvine in mathematics and her MS at the University of California, Los Angeles in statistics. She's the current chair of the NCTM ASA Joint Committee, a lead author on the new jointly published ASA NCTM GAISE-2 report, and author on the ASA SET report. Dr. Bargigliotti's interests are in non-parametric statistics, statistic education throughout the K-12 grade bands, data visualization, and multivariate models. She has received over $4 million in funding to carry out her research and published over 50 research articles, columns, reports, open eds, and book chapters. She is also the recipient of the ASA's Waller Award, Mu Sigler Rose Ward Award, the Dex Whittingham Award, and the Elizabeth and Michael Rudinica Prize. Christine Franklin is a senior lecturer emerita in the Department of Statistics at the University of Georgia and currently serves as the ASA K-12 ambassador. She has an extensive list of achievements, notably recipient of the Georgia Council of Teachers of Mathematics Gallaudet Thompson Lifetime Achievement Award in 2017, American Statistical Association Founders Award in 2014, and the USC's OTS Lifetime Achievement Award in 2013. She also served as the chair of the American Statistical Association sponsored strategic initiative, SET, the Statistical Education of Teachers, and served as a chief reader for the AP Statistics exam. Dr. Robert Good is currently the vice chair of the Department of Statistics and director of the Center for Teaching Statistics at UCLA. He received his PhD at the University of California, San Diego in mathematics. He is a fellow of the American Statistics Association and has been chair of the AMATYC ASA Joint Committee and the NCTM ASA Joint Committee. He is founder of the ASA Data Fest and co-chairs of the Data Fest Planning Committee. Dr. Good's research interest is in statistics education, and he was lead principal investigator in the Mobilize project, which created the Intro to Data Science curriculum, the first secondary level data science course in the country. He co-authored the Introductory Statistics, Exploring the World with the Data Analysis textbook with Colleen Ryan and Rebecca Wan, and he is founding editor of the e-journal, Teaching Innovation in Statistics Education. Without further ado, let's begin today's debate. First question, how to define statistics education and data science education in grades K-12, statistics or data science? Rob, your response.
Well, thank you. So as that bio says, I've been part of a project, the Introduction to Data Science project, that was a collaboration between high school teachers and administrators, computer scientists and statisticians, and to create a year-long high school data science course. And it's been going for about 5 years. And to date, we've taught more than 10,000 students. And a lot of my opinions have come from observations and participation in that. So first, I think to clear the air, when we're talking about K-12 education, at least what I mean, and I think I share this with a panelist, is we're not talking necessarily about preparing future data scientists or statisticians, or even preparing people who are going to college. We're talking about the kind of core knowledge that we think all students need, that all citizens need. So breaking that question down, first, why data science at K-12? And for me, it's a combination of perils and promises. So the perils are pretty well known. There's vaccine denial, there's confusion about spreads of the pandemic and how to adjust to it. There's a mistrust of science, there are data breaches, there's algorithmic bias, there's all sorts of reasons why it's important that we know more about data science. But there are also promises, and the promises are that pretty much every sector of the economy needs people with some level of data literacy or data acumen, if you will. And this is true at every level of every sector. So those with high school diplomas, up to PhDs. We live at a time where software is inexpensive to free and data is plentiful. So there's really no reason not to teach people to analyze data and to understand what's going on. So that's why we need some form of data literacy, data acumen education. So why not statistics? Why are we talking about that? I think, if you're a statistician, as I think most of us on this call are, if you look at the school standards, you'll not quite recognize them as statistics as you know it. And one reason for that is that things were filtered through a layer of mathematicians and politicians and compressed into these standards, which are very haphazard. In addition to that, often in many states, the stat standards are not assessed, or if they are assessed, they're given very little weight. So they're often skipped. They don't use computers. They emphasize inference without the necessary exploration and data visualization that comes before it. So so basically, I see data science as a chance to reboot, a chance to open up a new door and consider a solid K-12 pathway that teaches students to ask questions, to collect data, to organize, store, transform, wrangle data, to communicate what they're finding. It's an opportunity to prepare future citizens to be constructively critical, not just blankly skeptical of data-oriented arguments, to participate in a democracy. And the last theme I guess I will mention is it's also, well, two of the last things. One is it's an opportunity to consider data science and statistics as its own discipline and not in competition with other disciplines. And the last is it's an opportunity to reconsider the calculus pathway. And there's been a lot of attention brought recently to the fact that our whole K through 12 math pathway is geared towards preparing people for calculus. Calculus is really not necessary for all students, but I would argue that, that some form of data acumen is necessary for all students. And in fact, for a majority of students at all levels. And so this is an opportunity to prepare students in a way that's better fitting to our democracy and to our economy. And I'll close with that.
Okay, to you, Chris.
Okay, well, thank you. And first, I want to thank NISS for having this webinar. It was really exciting for me when I saw that you had picked K through 12 statistics education as a topic that we could talk about. Well, Rob said it well, and I'm not sure that I can add any points to what Rob has already said. You can imagine this is a question that I've dealt with quite a bit. The whole, do we say statistics? Do we say data science? It's really interesting. I thought I would share in my response here the fact, some anecdotal information, evidence. I've been real fortunate that my husband and my two sons have ended up in careers where data science has been an important part of their careers. And I would say all three of them do not think of themselves as statisticians, but they think of themselves as data scientists as part of their fields. My husband, who's a physician, at the latter part of his career, got into clinical informatics. In fact, he got himself board certified in clinical informatics. So he deals with data science quite a bit. My older son is an academic in forestry. He considers himself a data scientist in the context of forestry. And then my younger son is in cybersecurity, and he uses data analytics every day. And in my conversations with them, I talk about what they see as data science. And interestingly, they all think of themselves as working in data science because of using statistics, using computing. But all three of them tell me that one of the big issues they deal with the most is the fact that people don't necessarily question the data. They don't interrogate the data. They don't think about where the data comes from, and is the data really answering the statistical investigative question that they're after. And to me, this is what's always been core about statistics and the practice of statistics. And I think we refer to it, of course, in GAZE as the statistical problem-solving process. So my contention has always been that there is no statistics versus data science. We're still practicing statistics, but we just have new tools now, and we have emerging types of data that we're dealing with. And so I would contend that K through 12 is where we need to start. We also need to expose our students at a very early age to the importance of statistical reasoning, regardless of what field they go into, so that when they go to college and they're in their respective fields, they don't consider statistics a hassle, but an integral part of their subject area. So I'll stop there.
Thanks, Christine. And Anna, do you agree or disagree with what has been said?
So I agree wholeheartedly with everything that both Rob and Chris said. I can add a few things, and that Chris was sort of starting to touch on there at the end. So there's this notion that, you know, we're preparing data scientists, as Rob mentioned, but in fact, we're really preparing at the K-12 level, we're preparing students to be active members of society, the world, world society. And there's data everywhere at this point. And even at young ages, kids are taking pictures, they're tracking their steps on Fitbits, for example, and devices. They're engaging with apps like YouTube and getting suggestions from YouTube about what they should watch next. Netflix, even their athletic events and youth sports are inundated with data and information for them. And this is happening at, incredibly young ages. And so we need to teach students or get students to understand how to deal with data from the beginning, how to understand risk, how to understand and just thinking in terms of variability. And as Rob mentioned, I think really wonderfully put, is that when you look at what our K-12 standards look like currently, we miss sort of the statistical investigative process, which as statisticians, that's the pillar for us, right? Mm-hmm. So as Rob said, it's often not recognizable what's happening in the classes or what's happening in our curriculum. To a practicing statistician, what we're doing now with data science is what statisticians have been doing all along. It's just, we have new tools, as Chris mentions, we have computers, we have very fast things and algorithms and precise algorithms and whatnot. And so what we really need to understand in this new evolving data science or this new evolving statistics is, how do we question that data that we're using, and how do we use questioning throughout the process to guide our analyses and to guide our interpretations and to even guide what we're looking for, guide our questions. So I think we'll probably bring this up several times today, but I think all of us probably agree that this dealing with data and understanding data really starts at such an early age, because at such an early age, you're being exposed to it. So addressing that exposure right away is really important. And as Rob mentioned, in K-12, we're not necessarily training people to go to college. Many people finish at K-12 and 12 and do not continue. Data science degrees at the college level have been popping up everywhere, and they're pretty consistent about what they look like at the college level, which I'm sure we'll get into later. So I'll stop there for right now.
Thanks, Anna. So it is important to start statistics and data science education in grades K-12. So this brings up the next question. Is statistics and data science education too ambitious a goal to pursue at this level for both the students and teachers? Chris, would you like to respond?
Yes. So I'll take the first go at this question. I think the past 14 months have really challenged us with COVID, and I think more than anything have demonstrated for us, as Rob mentioned earlier and Anna has, that being able to reason with statistical information is more important than ever. And I'm a firm believer that becoming statistically and data literate should be as core to our school level curriculum as reading and arithmetic and writing. So with that said, is statistics and data science too ambitious for students? Well, I would advocate that it's not. And I think Anna really led into this nicely when she talked about how even at a very young age, students are so interested in learning about themselves and collecting data. And I think the other thing we need to remember is that decades of research from many people internationally have demonstrated that students from an early grade zone can thrive and become very excited about curriculum that involves data. So the research is out there. Statistical thinking, just as mathematical thinking, I think must begin very early, and it needs to evolve over the school years. I think that's always been a fallacy, that we think that we can turn our students into statistical thinkers with one college or AP statistics course, which is not the case. We need to start at kindergarten. And students really latch on to the relevance and the context of the data, especially as it relates to them personally. And I think the other thing that happens is students actually begin to see connections between the mathematical concepts that they're learning at the school level when data is involved. And to me, that's very important, because how many students tell us they don't like mathematics, they don't see the relevance of mathematics. And lastly, as Rob and Anna have mentioned, we've got to grapple with the fast changing nature of data. Now let's get to teachers. There is no question that it is not too ambitious for teachers to teach statistics, because we have examples of those teachers all over the United States and internationally as well. There's just a wealth of master school level teachers that teach statistics. I think the big challenge that we have is that unfortunately, most of our teachers have not received the training that they need to teach the statistics curriculum that's in place. That was just not part of their traditional teacher preparation programs. So what we have to think about is how we can train our in-service teachers, the ones currently teaching, as well as the ones that are currently in teacher preparation programs. And there really is, there's well-structured professional development out there. If you look at your resource sheet, you'll see that Holly Lynn Lee at NC State has some wonderful free online professional development in the form of MOOCs for teachers. There's also going to be a book coming out from the joint ASA NCTM committee soon that can be used by teacher educators. I think the other challenge that we have is not only getting the proper training for our current school level teachers and future teachers, but we also have to work with our teacher educators. Most of our math educators who are responsible for training our teachers in statistics will be the first to tell you that they're not comfortable with knowing what they need to do in their teacher preparation programs to get teachers ready. So we need to work with them. And there are many national organizations that are doing that right now. AMTE, ASA, NCTM, the Supervisors Organization. So there are efforts in place. And I guess I'd like to say finally, the third point that I think we need to think about is we need to have a change in the culture of our schools themselves as to the relative importance of teaching the statistics standards. I think Rob and Anna both have mentioned how the standards are all over the place. And I think what has happened is that schools have taken the approach that, well, we're just going to ignore the statistics standards and focus primarily on the algebra and geometry standards. And a lot of that has been led by the assessment that is out there. So I think a big point is that the culture has to change to where statistics and data science, whatever we call it, is important, and professional development for our teachers is made a priority by schools themselves. So I'll stop at that.
Before I follow up with Anna on this question, I just want to mention that our panelists have prepared a list of resources. The link is made available in the chat window. So if you open chat window, you'll be able to see the resources. And my understanding is that our panelists will refer to the list several times during today's debate. All right, Anna, would you like to follow up?
Yes, absolutely. So I agree with Chris, shockingly. No, I think we're going to agree on most things, but I do not think it's too ambitious. I think it's ambitious, but it's also a requirement. So I think ambition, whether or not it's too difficult to pull off, is really not an option anymore, because data are so prominent in our lives. And as Chris mentioned, it's just as important as reading and writing. So I don't think we're at a time anymore where this is an option to not do this, regardless of how difficult it might be to implement. With that being said, I actually don't think it is that too ambitious. A lot of the examples we put in the GAZE 2 report were examples that were used and vetted with students and teachers before at all grade levels, including some examples in the level A of the GAZE 2 report that were vetted with students as early as kindergarten, and several times with different classes, and went exceptionally well. I also, since Chris had an anecdotal evidence in the last one, I'll tell a little bit of an anecdotal story on this one. So a lot of kids in the United States participate in youth sports, for example. And right now it's baseball season. So lots of kids, girls and boys across the nation are participating in baseball. And they have batting orders when they go up to bat. And most of us sitting in the stands, if you watch a little bit of baseball, if you're somewhat familiar, you kind of know that there's certain characteristics of each batter and why you put them in that order. To try to draw in more runs and score more points. The kids have no idea. They just walk up and try to hit the ball and come back, right? But it would be really interesting, for example, from a data science perspective or from a statistics perspective, for students to understand that decision that's being made about them within the context of youth sports, to track the game, see what they're doing, and show them what the reasoning is for putting them first at bat or fourth at bat or fifth at bat. And even small things like that, that have data behind them, and that often coaches are making those decisions based on data, whether consciously or subconsciously, but they are making those decisions based on data. Why not incorporate students into that? Those types of activities that they are partaking in that will enrich sort of their lives to understand how the decisions are being made. And I don't think that's too ambitious. I think students are incredibly excited when they're seeing the decision-making that's happening based on data that has to do with them. With respect to teachers, I agree with Chris. I think that the challenges are with teacher preparation, because those programs are historically have not had so much room to put statistics in them or data science in them. However, again, I think we are at a time now, we've reached a time where it's no longer an option not to teach this. And we've sort of seen, even in the last 14, 15 months, the repercussions of not having a data literate populations with vaccine hesitancy, risk analysis issues, and I think we just are embarking on a time where this is just a must that we do. And so how we figure that out of how to do it is up to us, but we must do it. And I'll stop there.
Yeah, so I guess I would say it's teaching data science is much less ambitious than teaching Algebra 2. We have lots of evidence that Algebra 2 is a complete failure as a class, and yet we persist. But that's not to downplay the challenges that Anna and Chris are saying. And I think, one big challenge is professional development. Back in the 80s and 90s, there was a plethora of literature, Dick Schaefer, George Cobb, David Moore, and many others reminding us that statistics is not mathematics. It's a different way of approaching problems. And in some ways it's orthogonal to the mathematical approach. And the implication of that is that we need to do teacher development. There's some interference coming. We need to do teacher development so that they learn this new way of thinking. And I think, there's several AP, I'm getting feedback. There's several AP teachers on the list who maybe can tell us their stories about the conversion of coming from math to statistics. But I think, when I've spoken to teachers who've done it, they all talk about how different teaching statistics is in many positive ways. So it's worth keeping that in mind. The other thing we haven't talked about too much is the preparation needed in computation. So I think, we as a community don't yet know too much about how to prepare students to think statistically with computers. And that's an area that we still need to explore. But I think computers make the topic much more accessible than they can replace mathematics in many ways as the language, as a way of communicating and marking models. And students like it because, unlike mathematics, the computer models are interactive, tells them when they're wrong. It tells them what they're seeing. Doesn't always tell them when they're wrong, but it does tell them when they're very wrong. It lets them explore. They can use it to communicate to each other. We've been teaching our students to use R in the high school, and they really love it. And they take to it fairly quickly. but it does take more professional development. The last strand, I think, which my colleagues haven't yet mentioned, is we are lacking in, or Chris touched on this, we're lacking in assessment in data science. I think as a community, we're still trying to come to a consensus of what it is. But one thing we found was there are some great assessments for assessing statistical thinking. Tim Jacoby's Locus is one that we use. There's some great assessments for assessing computational thinking, but there's nothing that gets at that synthesis of when students are doing both at the same time. And if there are any new budding researchers out there, that's the area I think we really need work in, is to be able to identify just what that is when students are thinking statistically on a computer, and being able to assess that.
Come back to you on this one. Oh,
I think you bleeped out a little bit. I couldn't hear you.
okay. Oh, yeah. I was asking if Chris would, or Anna would like to respond to Rob. Okay, so I actually have a follow-up question. Is it more practical to argue for data science to be integrated throughout the K-12 STEM curriculum? Or is it more manageable from a bureaucratic and pedagogical perspective to free up one full year in high school for data science, say combining Algebra 2 with either Algebra 1 or pre-calculus?
Well, I'd like to take that if I could. So I think that's a false dichotomy. We shouldn't be talking about data science or calculus, or data science or Algebra 2, unless we mean the inclusive or. I mean, I think both options need to be available to students. I also think it's a mistake to think a single data science course is going to solve our problems. Like Chris was saying, we need to integrate it from K-12 through the beginning, because you just cannot learn this in 1 year. We have a lot of evidence that you can't learn this well in 1 year, much less 1 quarter, like we think at UCLA. So it really does take a lot of time to build up to that. I do think it doesn't need to be in a math class. It is friendly in science classes. It is friendly in computer science classes, but math is kind of the natural place to house it. And then the last point I'll make is interdisciplinary work in the high schools is extraordinarily difficult. The structures just make it very challenging to carry off. So that's another argument for housing it in one discipline such as math, and trying to encourage more connections to be made. As people have pointed out, data science and statistics require substantive application. You have to be immersed in a context. And that's one of the challenges math teachers face, is they have not always been exposed to that sort of thinking in a context before. But again, that speaks to the need of professional development. But it also speaks to the need for making sure there are data science modules and experiences in other sciences and social sciences and humanities as well.
I can make a comment just as a follow-up to Rob. It's interesting. I agree, Rob. It's very difficult to do the interdisciplinary at high school just because of the way the structure of the courses are. But one of the more natural places is at the early grades in the elementary. And I have found through the years that in working with elementary teachers, they latch on to the data and to the statistics because they are structured in such a way that it's so easy for them to incorporate it in all the courses that they have at the elementary level, not just the mathematics courses or where they think a certain home should be for the statistics. So I think that's another reason why we need to start it early.
Anna?
Well, Chris took what I was going to say. So I was going to say exactly that. So I think thinking about it as the siloed course in high school or at the college level or whatnot is in some ways missing the, well, not in some ways, it's missing the point. So we want it integrated. So as Chris mentioned, in the K-5 grades or the pre-K-5 grades, because of the structure of teachers being multiple subject credentialed, and because of just the way that students are with one teacher all day, there is such an opportunity to go across subjects, math, statistics, science, social studies, and do activities and do lessons that are really focused on data in the context of the larger things that are happening in their classroom. And this offers a really nice opportunity to get in data science and data literacy in the early grades. As we get farther along in the curriculum, in the K-12 curriculum, in middle and high school, I think we really need to think about what our goals are and how we achieve those goals. And the goals, as Rob said, to think statistically with computers, and that's how we're thinking of, that's modern day statistics, or we can define that as data science if we want. We need to think about where does that play out in a curriculum, and then in all those places where data comes out, then it needs to be there. And putting it in sort of this one course is kind of a difficult sell. And also, as Rob mentioned, this notion somehow that statistics or data science is opposing AP statistics or AP calculus or calculus. I fear that this is a very slippery path to go down. There are, for those students that are planning on going to college, calculus is integral to many majors, particularly the STEM majors. And I fear that if we pitch this as if something is statistics is sort of being pitted, or data science is being pitted against calculus in some ways, and then students are self-selecting into data science or being pushed to do data science, that means they're self-selecting out of STEM majors later on. And how we deal with this idea is unclear yet of what we do here. But I think the data science for citizenship, or for members being a member of society, is really the right way to think about this. And when you think about it that way, then the ideas of data science pop up everywhere, and then it should be integrated everywhere. So I'll stop there.
Discussions. Next question. Has K-12 statistics and data science education been successful so far? By what measures? Anna.
So I think this is actually a really challenging question. As was mentioned, we got the questions ahead of time. So I thought a lot about this question of how to answer it. And I think in many ways, yes. And I think in some ways, no. So I do believe that statistics and data science education is succeeding in many ways. So first of all, we're having this conversation. So that in itself is a huge success. People are interested in this. Statistics has a place in the K-12 curriculum, really prompted by NCTM's principles and standards back in the 2000s, in 99. And with that, it solidified that statistics has a place in the curriculum. So even that in itself is a big win. We also have guidelines through the GAZE 2 report, which offers many points on data science and statistics. And that is a huge win. We also have examples of data science curriculum at the high school level, like Rob mentioned before, his IDS curriculum, and it's been going for 5 years, and this is a huge success story in itself. We also currently are seeing many states moving explicitly towards placing more importance on working with data and data literacy in their standards, with my state, the state of California, putting this as one of their frameworks highlights. So these are big wins. And I think it's really important to recognize that. And just overall, I think the discussion surrounding data, even with friends that have nothing to do with academics or science or whatnot, they talk about data. So there's a real appetite for this. And these are really, to me, really showing success of just data science and statistics education. These are all positives, but of course, I think we need more work. I think educating a population that's data literate in today's version of data literacy, which looks very different of what data literacy looked like maybe 20, 30 years ago, is challenging. And some of those challenges are particularly surrounding computing. Statistics and students need to have much more computing, but simultaneously, and this is the key, as Rob kept saying, or has said a few times, it's computing simultaneously with statistical thinking and simultaneously being able to question the data provenance. And I think I want to spend just 30 seconds or so talking about data provenance, because understanding where data comes from and how the data were collected. So that really means study design to those of us who are statisticians, but is such an important part of data science today. And understanding what the limitations, the biases, the ethics that are involved in collecting data through apps, through sensors, information on us. These are real issues, and we need to do a good job educating our students on these issues, I think, and these are not easy issues to educate on. Students, I think, desperately need to think about the statistical process. Statisticians are not merely number crunchers, and that statistical investigative process that we talk a lot about in GACE 2 is such the pillar and the cornerstone of statistical thinking. And that really, I believe, should be emphasized much, much more from really early on. And just overall, that questioning is so fundamentally crucial in this process. And it's nowhere near emphasized enough in our current curriculum, and including in college at the I'll say this as the K-16 level all the way through. I think we are trying in some college courses to really put that questioning at the forefront, but it needs to do a much better job. And then, as we've already mentioned, the teacher prep situation is lagging a little bit behind from where we should be. And I think as states are pushing more, which is wonderful, and are pushing more to put statistics and data science more prominently in their frameworks and in their standards, we're going to see teacher prep in a year or two start catching up to try to respond. It would be nice if we never play catch up and we anticipate things together, but that's a difficult challenge, I think, for all of us.
Your reactions, Chris? Oh, Chris, you're on mute.
Yes. Well, I agree with Anna. I think the big measure that I'm using right now is we're having this discussion, which is big. So I'm going to admit my age. I've been watching this process of K through 12 statistics education since the 80s. And I have to confess, there's been ups and downs for me in terms of at times I think we have a real momentum, and then I think we take steps backwards. But when I reflect on where we've come since the 80s, there's a lot of successes that we can be really proud of. I think one success is that we have organizations, national organizations, that are supporting this effort. Not only the ASA, and thankfully it is one of their top priorities, but we have other mathematics organizations, math education organizations that are very supportive as well. And to me, that's very encouraging. I think another set of encouragement to me, to add to what Anna has said, is to see the momentum that we have right now in the states that are actually revising their standards and seriously discussing more statistics / data science in their curriculum. I'm very fortunate actually to be in a state, Georgia, where they just finished revising their math standards. And Georgia is actually part of the Launch Year project out of the Dana Center. And Georgia made the decision to, in revising its standards, to introduce a data and statistics strand starting in kindergarten all the way through high school. This was big. And secondly, they also made the decision to go by the way of pathways with their high school curriculum. So for example, their Algebra 2 course, which is going to be a course that all students have to take in Georgia, is now 65% algebra, 35% statistics, data science. That was major. But I think another major success with all of this has been that part of the motivation for Georgia to do this was the fact that our university system in Georgia came to the Department of Education asking them to get more data and statistical literacy into their math curriculum because they wanted to see more students coming to our colleges and universities with that background. And to me, that's a major success, because one of the things that I believe has always been a stumbling block for us with K through 12 education is the lack of coordination between the undergraduate level, the post-secondary, and K through 12. There seems to be a disconnect as to what the undergraduate programs want versus what K through 12 seems to think should be the curriculum. So I just wanted to add that, as I do think there's been some major successes, but we still have a long ways to go.
Further responses, Rob?
Yeah, so they both gave a more optimistic answer than I was thinking of giving. I agree with Chris that there have been successes, but I don't agree that we've been successful. The successes we've had, I think, you know, there are people on the Zoom call who've been responsible for some of them. I do think the AP Stats curriculum is one of the successes in the sense that for the first time ever, we had students coming to the university already knowing what statistics was and knowing whether they did or did not want to major in it. But I think the AP's reluctance to take computing seriously is really holding it back. And I think, to me, that really speaks on one of the key issues of that we need to improve is how we assess whether there were a success. And I think we often are assessing students within the context of the curriculum, but as a community, we should be assessing against whether the outcomes are matching what we want to see the students doing. And let me just give a quick anecdote. A couple of years ago in my intro stats course, that was a pretty advanced class of students. I mean, you know, a general ed class, but still a pretty elite group of students. I teamed up with a librarian to give them access to a data repository that had kind of easily accessed data sets that were tied to journal articles. And I asked them to go and find a data set on a topic that they enjoyed and do a graphical analysis, pose some statistical questions, do a graphical analysis. I thought it would be a fairly easy 2-week project. Instead, we spent an entire 8 weeks teaching them how to download the data and what a .csv file was and what it meant to have tabs that were invisible, and the simple fact that not all documents had to be opened in Word or Excel. So there was just a lot of basic computation literacy there that students didn't have. And I thought, what good are we doing teaching them how to think statistically if they have no data upon which to apply this skill and they're not capable of accessing that? So I think for me, one of the big eye-openers in developing this IDS course was how liberating it was to not have to think about one course. We saw IDS as a precursor to AP Stats, so we didn't have to teach formal inferential thinking because that happened next year. And when it did happen, the students were ready for it. And we saw IDS as coming after an introduction to programming, so that they were learning computation in another course, and in IDS they were applying it. And I think, you know, if I have a dream, one of those, or of my dreams, one of them is to establish a kind of universal data science pathway in high school that runs parallel to math and runs parallel to the science pathways, that has heavy doses of computation, heavy doses of statistics, and you know, some sort of culminating data science project or something along those lines. And I think, you know, when that happens, I'll consider this a success.
Great. So we kind of touch upon the next question a little bit, as all of our panelists are advocates for data acumen for all. So can data sense or data acumen be trained well in K-12 or even younger? Are there any unique challenges and benefits of developing data acumen in K-12? Anna, would you like to respond?
Sure. So I think of data acumen of being fluency with that statistical investigative process. So to me, that's what it means to have data acumen. And certainly the statistical investigative process should and can be taught even at the youngest ages. And just to give a parallel, imagine if we did science, for example, in elementary school without the scientific process in mind. So to me, it's the same idea. How can you work with data at any level without having investigative questions, questioning your data, interrogating your data, analyzing your data, and interpreting your results? So it's the same sort of parallel to me there. Now, the challenge rests in developing a scaffolded data investigations throughout that kind of get more and more complex as students develop. We spent a lot of time in the Gaze 2 report when we were writing and talking about it, actually, and then writing it, trying to think about the types of questions you use to initiate data investigation for the different sort of age brackets, if you will, and how those questions can become more and more complex as you go along. So we can use, it's my opinion that we can use questions, the investigative questions as our guide throughout the levels. And yes, maybe in the really early grades, you're not going to use the same investigative questions that you would use as juniors in high school, for example, but you can see sort of this progression of types of questions that go through the levels, and that those questions indicate what types of data you need, what types of data collection and study design you need, what types of analyses you need, and et cetera. And with that, data sets could become larger as you go. The types of analyses and methodologies used become more complex, but that process, the statistical investigative process, is still the crux throughout, from early to on, just like the scientific process is for science in K-12. And teaching this process, again, is relevant at all levels. We don't just look at graphical displays, for example, just for fun. We don't just look at a graph just for fun. We look at a graph to understand something and to understand whatever the graph is trying to show us. We look at we need to encourage students to interrogate and question the data provenance of the data put to use to make these graphical displays or visualizations, as we're calling them now. And we can move from smaller data sets to larger data sets at all levels. So we can use larger data sets if the computing's there at the younger levels as well. And we can use smaller data sets at the upper levels as well, depending on what your statistical investigative question really is. And that's what guides sort of the process to begin with.
Your response, Rob? You're on mute, Rob.
I don't have too much to add to what Anna said, so I think I'll pass on this.
Okay, Chris, do you have any follow-up comments?
I'll just make one quick addition to what Anna said, which I totally agree with. When I think of data sense or data acumen, I too think about the importance of the questioning process. And once again, I'm going to emphasize how natural it is to start at the early grade levels with this. Our young students are full of questions. I mean, as a parent, we all know that, you know, as our children begin to talk and as they are growing up, sometimes they're asking more questions than we really want to deal with. The same is true in school, and with teacher guidance, it's just so natural to think about exploring investigative questions that students come up with, and very natural to use sort of the what do you notice, what do you wonder process as well. So I just wanted to emphasize, once again, I think this is a real strength of starting this very early.
I did think of one thing I wanted to add, which is that we can't afford not to teach data acumen. So we have no choice but to teach it.
Okay, so in the Gaze 2 report, it mentions that students today are encountering a greater variety of data types and data sets in different sizes. So in grades K-12, small data sets or big data for teaching and practice purposes?
Am I first on this one, I think?
Yes. Oh,
Okay.
please.
Yeah, so I guess the question is how big is big, and at what level should students be exposed to it? You know, I guess I see that Tim Erickson is on this thing, and I quote his phrase often that students need to have the experience of being awash in data. And part of that is to give them a sense that there are strategies and tools to apply that help them get out of that sense of drowning in data. And learning to ask statistical investigative questions is one of those tools. But it also does speak to the need of teaching some computational acumen as well. I think when I think of big data in K through 12 education, I'm thinking in terms of the number of columns. It's important that students learn to think multivariately, with multiple variables, in part because they naturally do. And we had lots of cases in our IDS classrooms where students often wanted and posed multidimensional, multivariate questions. And the teachers, before they were more versed and more experienced in this, would get frustrated because no, the question they asked just had 2 variables and now you're bringing 3 and 4 variables in. And so that's a great thing that students naturally think that way. And so we need to give them data sets that let them explore that. There are advantages to give them really long data sets as well, to give them so they can't get in bad habits of just kind of quickly scrolling through to get a sense of everything that's in the data set. They need to learn some tools that help them to grok, to comprehend holistically a data set, without counting on being able to scroll through the spreadsheet. I think this is a good point to mention that we still have a lot of basic research to be done. I see some questions coming up in the Q&A about, when do we teach data wrangling? How much do we teach data wrangling? And that ties directly to how complex data sets can we give to our students, not just in size, but complexity and structure. And I think we have a ways to go before we fully know that. I'll point out a study that opened was a revelation for me. Cliff Canald and Bill Finzer and someone else I can't remember offhand did this fantastic study where they asked students to observe some situations and record those situations as data. And part of their conclusion was that many students naturally think in terms of nested models or hierarchical data structures, and not in terms of a flat Excel sheet file. And for me, this was an eye-opener because it meant that the spreadsheet format that we were starting students with was unnatural to them, that they were conceiving of data in a different way. And their research led to some more research, which is showing that we really do need to teach students to think in terms of this case attribute sort of structure for handling data files. And that to me opens up the door of, well, how do we teach to think more complexly of multiple data tables and things like that? And where do we integrate that? So I think there's a need for more research before we really understand just when we can introduce complexity in data and how much in terms of the structure of the data. But back to the basic size question, I mean, I don't think K through 12 students need to be learning Hadoop, for example. I mean, I don't think that that's an important part of the K through 12 experience. That's not to say that some students won't really get excited about that in a class or a project of some kind in high school when they understand, the need for it and don't just get lost in the mechanics of the process. But I think the most important thing is that children at every level need to have what Tim calls the experience of being awash in data, and they need to learn some tools at that level for that level of complexity that lets them get out of that feeling of awashness.
Hannah, would you like to respond?
Sure. I'm going to add a couple things. So I completely agree with Rob, and then I'm going to add a little bit on thinking about maybe not necessarily small and big versus big, but on type. So type data are no longer just sort of categorical variables and quantitative variables, we can think of data now as text messages, audio clips, photos. These are data that our students are just in our daily lives. We do this all day. In fact, many of us document our lives with photos, right? We post photos, we take photos of things, and we communicate this way a lot. So another way to think about data in K-12, or the types of data that you can have students experience, is to thinking about sort of these, I'll call them unconventional types of data, and having them work with that, which requires multivariate thinking most of the time. Rob mentioned this idea, this notion of thinking like in the case, in a hierarchical case. A couple things actually on that. So pictures offer a really nice way to do this, where like in K-12, where students take series of pictures of something about their lives, and then they get compiled into this picture data set. And then using this picture data set, it can be interrogated to ask a bunch of questions and answer and analyze these questions. So there's a few articles that are coming out soon with examples on exactly that, like using pictures as data with as early as elementary school students. Another thing that comes to mind is the data cards. So data cards where students can be surveyed, or students can do something, or their schools or whatnot, and create like a little card, and they can physically do this, or they can think about this in a spreadsheet form or whatnot, where all the information for their case, for that unit of observation, is captured in this card. And this is something that I believe, Chris can correct me, but I believe originally started in New Zealand, where they use these data cards. And there are a couple articles, and Chris mentioned the book earlier, that have information about that. So not only, I think, are we thinking about small or big when we're thinking of data science, but we're also thinking in terms of type and complexity of type. And I think it's important to think about both of those in this context.
Chris, any thoughts on this?
Well, I'll just add to the excellent comments that Rob and Anna have made. I think students at the school level, even at middle school, upper elementary level, need to be able to work with messy data as well. And this is not something that needs to be held off until students are undergraduates in college. And there's a wonderful source that you can use. If you look on the resource sheet, you'll see that there's Census at School, which you can access from the ASA website. And the nice thing about Census at School is it's student data that's been collected, but oftentimes it's messy data. And so it gives students the opportunity to think about cleaning their data and getting it in a manageable form that they can work with. Anna mentioned that there's a couple of articles that are coming out. One article will be in the Harvard Data Science Review. On your resource sheet, there's already 2 articles that have come out about GACE 2, the Introduction to GACE 2 and Level A. Level B will be coming out soon, and this is an article that focuses on using photographs. The other article that's coming out in June is in the NCTM MTLT journal, and it also focuses on using photographs. And then I might also mention, let's see, if you look in the GACE, one other piece on the resource sheet is the lizards and the ladybugs. And that will also give you a sense of the level A of using non-traditional data, but it will also give you a good sense of how to evolve with questioning from level A to level C. So I just wanted to mention some examples that you could pull from the resource sheet that would support much of what Rob and Anna have said.
Great. So let's move on to the last question of our pre-select questions. To keep up with the demand for data analysis and problem-solving skills from a fast-changing data-driven world, are core statistical and mathematical concepts changing? Chris, would you like to respond?
Right. Yes, I'll take the first go at this. Well, I'm just going to repeat a lot of what's already been said, I think. I can talk about the statistical concepts. Uh, the answer, I think, is no, because I think the core statistical ideas and the pillars of what we're doing is that statistical problem solving process and this whole idea of questioning through the process. And as Rob and Anna talked about with the previous question, regardless of the type of data we have, whether it's traditional, non-traditional, whether it's primary or secondary, whether it's small data sets, big data sets, that is key. And to me, that's how our standards need to be focused starting in kindergarten all the way through high school, is around that pillar of those 4 components. And then as students advance from one grade level to the next, they're just picking up a different set of tools to put in their toolbox as they think about going through that process. I think maybe the other thing that I want to mention that I think is a core concept, and this is both for mathematics and statistics, and we haven't talked a lot about it, is communication. And communication is key, especially in statistics where we're trying to take data and deal with the ambiguity of variability, and we're trying to communicate information and what's the story that that data tells. And one of the things that I've learned from my husband and from my 2 sons as they work in their respective fields and they're working with data, they do not claim to be statisticians. They were not trained to be statisticians, but of course they have to use statistical reasoning, they have to use computing, etc. But what they emphasize is critical is not only the process and the questioning, but also the communication with the context expert in that field. So, for example, with my husband in healthcare, you've got your doctor and then you've got your data scientist. And for my son in forestry, you know, he does a lot of the analysis himself, but he's oftentimes going to the statisticians in the statistics department at his university to get help, but he's still the context expert. And then, of course, my son in cybersecurity, same thing. So those core concepts must remain there. As far as what's happening at K through 12 right now, we talked a little bit about how states are revising their standards. A lot of what's happening with the revision of those standards is based on work that's promoted by NCTM with their catalyzing change reports. And that is, for example, at the high school level, they propose that there needs to be a core set of math courses, depending on states, whether they have 3 or 4 units requirement, where there are some courses that all students take that include both the mathematical strands as well as the statistics strand. And there's essential learning outcomes that all students need. And then we talked, Rob mentioned these pathways that students can then take for their junior, senior elective courses. So I think that there's a lot going on with the revision of standards where there is an overall revisitation of evaluating and asking the question, what are really the core mathematical standards and the statistical standards that we need in our curriculum? With the advances in technology, do we still need some of the mathematical curriculum that we've been teaching all along? Do we still need to require all students to try to strive for the pre-calculus course? Or can they strive to get through to Algebra 2 and then take these different pathways? So I'll stop there.
Anna, would you like to respond?
Sure, I'll add a couple things. So I do think, I completely agree with Chris that I think, as we've said, the statistical investigative process, that pillar has stayed and certainly should be continued to be the main core concept. with that, as computing has evolved and access to computing has evolved, I think it's easier and important that we teach computing to our students. We do not want to be in a situation, as Rob mentioned, where undergraduates are coming and don't realize what a .csv file is. Like, this is where we should be past this at this point, right? And so this is a pro of the pandemic, right? Because the pandemic brought so much technology to K-12 that students are a lot of students, I shouldn't say all students, but a lot of students are extremely used to now working in shared drives, Google Classroom, downloading things, Flipgrids, all these sort of tools that have been used and technologies that have been used in K-12. Google spreadsheets. Students now know how to do this as early as, first, second grade in some areas. So I think we can capitalize on this a little bit and push our students to compute more or use computational thinking. And a lot of that in the early grades is about organization. It's organizing your information or your data in a space that is in a computing space. And then we slowly sort of get to coding, but even understanding how to move columns and whatnot in a Google spreadsheet or defining new columns, that can happen very early now. And because the pandemic essentially pushed us to get there, right? So as we think about changes and core topics or core concepts, computing to me has really become a core concept that needs to be incorporated in tandem and connected to statistics and connected to data and connected to data science. So, and then just, I'm going to mention, I mentioned it before, but to mention it again. So if you go to college and you become a statistics major, you need calculus. So I'm going to reiterate it because I get really worried that by providing alternative pathways and phrasing it as pitting calculus against statistics or data science, that it is inadvertently going to squeeze out students from majors where we already have pipeline problems, particularly with underrepresented groups. And so I think we have to be very careful about, especially at the high school level, how we understand and guide and advise students to take these different things. And I think all three of us agree on the panel, what we are promoting is, and what I think we are promoting is, data science and working with data is now a societal need, period. That's why students all need to take it. With that being said, if you are going into a STEM major, you not only need that, but you also need to make sure you're setting yourself up to be able to be a STEM major. And I think we need to be really careful, particularly with underrepresented groups, that we are not putting them in situations where then they get to college and they are not prepared to be in STEM majors, because we already have major pipeline, not major, but we already have problems with pipeline issues for underrepresented minorities and women, and creating a situation where we're actually highlighting that is going to, I think in 10 years, we're going to be in a real mess. So I'll just leave it at that.
So I get to
wrap up?
I get to disagree. I both agree and disagree with Anna here. So I'm glad she brought up the need for teaching.
I figured this was going to be the one point we were going to disagree on.
It took you 45 minutes, but you did it. Yeah, so I agree that computation is really important and it needs to be taught from the very beginning. And this leads, I think Dawn Davis mentioned something about when do we teach machine learning. And I think, if we're teaching students about algorithms, if we're teaching them a little bit of coding, in our IDS curriculum, we teach them classification regression trees, building on that algorithmic knowledge, and they really take to it. I think even earlier, you can teach them about making predictions, and the core concept there isn't how to make a prediction, it's how to assess the accuracy, those different tools we use to assess predictions. That's something that can be taught in middle school and early high school, and can be built on, what precisely is machine learning, that maybe can wait, or the more elaborate tools can maybe wait, but with that background, maybe they can come earlier and earlier. Where I disagree, if I really do, we'll see, is that so the Cal State University system and the University of California changed their admissions requirements this year to allow a data science or statistics course to count as 1 year of mathematics. And they require either 3 or 4 years of mathematics for admission. So this means that it's possible that we're going to get a large number of students who are really strong computationally, have good data acumen skills, but haven't had Algebra 2. I think that's a university problem to get them into the STEM pipeline. I think the problem is that we've prioritized calculus. We've said that you either have to take it in high school or you'd better take it your very first quarter of college, and you better be prepared. I think speaking as a statistician, need to take a serious look at just what math students really need in that first year of statistics study and the second year of statistics study. I would just argue, with no experience behind this, but just as for the sake of a debate, that maybe that first year of college math needs to be a linear algebra course from a more geometric perspective, and maybe calculus comes at the end. Or maybe it's just done in a just-in-time sort of approach to tie directly to other statistical concepts. And this is a radical idea, but it's one that's being used. I mean, life science departments and programs around the country are starting to break up the math curriculum and piece it together in different ways that better serve their students. And I think, we haven't touched on this at all, but there's a big equity issue involved in prioritizing calculus. And Anna was alluding to that. And data science and statistics and computer science have a promising role to play in kind of improving that equity pipeline. But I don't think it's the burden of the high schools to think, well, we've got to be counseling students to do one or the other, but it's the burden of the universities and colleges to be accepting of these students who really, if you think of it, if you wanted to prioritize what's a better college skill, data science or calculus, I think many of us would vote for data science and start from working from there. But we have a long ways to go, unfortunately, I think, before we're ready for that. So that is the end of my advocacy argument.
With that, we must end our statistical debate here due to time limit. I think that our debate and discussions about the various aspects of teaching statistics and data science in grades K-12 will continue, and we will never stop. We have received many questions from our audience, so it is a great opportunity that we have our panelists here to address, hopefully, all of them. We apologize if we cannot address all of your questions, but we will make a list of resources available on the event page. So some of your questions may be addressed by the content of the resources. All right. Okay, so let's begin our Q&A session. The first question: should there be a the first question, how do we address the fact that most K-12 teachers do not already have the background to teach data science without adding to already overflowing plate many hours of training and professional development as they try to just catch their breath from all extra pandemic work and challenges? So our panelists, if you would like to respond, please just jump in.
Well, I'll start by saying I understand, and we all are feeling this kind of burnout sort of thing, and now we're advocating for more and more. But I think, it's important that this burden not be put on an individual teacher at a school, but I think it's something that schools as districts and larger administrative units need to prioritize. But I will advocate that I think a statistics and data science course is actually a great way of improving the emotional landscape of a classroom. Students enjoy learning to apply things. It gives students a voice. It gives them the tools and the ability to frame their own questions, to collect data on things they care about. So it lets students kind of it lets them implement some of their own autonomy and choosing what they want to study once they have some basic skills. And so I think, many of our IDS teachers have found that it's a joy to teach this class because the students really kind of become their own learners much more than they ever have in a math class. And that lifts an emotional burden in many ways.
Chris?
Yes, I just wanted to back Rob up. I think Rob is correct that this was something I alluded to before. I think this is sort of a culture issue within our schools and our districts and even within our states where this has to be made a priority. And it's not just individual teachers that are going to be taking the professional development, but it's schools working together as a team, districts working together. And I think once you set that as a priority and the teachers see it as a team effort, the sense of a burden hopefully is not as much. Although during what we've gone through this past year, that may seem difficult. But my experience has been also that teachers may at first be resistant to trying to go through the professional development to teach statistics. But once they incorporate it in their classrooms, they come back a year or so later and say it's the most engaged their students have ever been in their math classes. And they really start to enjoy it and become very enthusiastic about teaching.
Another question about training. For those who do not have statistics background and they're high school, how to start teaching statistics?
I can take this one a little bit. So I think that the ASA offers and NCTM offer a lot of resources with lesson plans, which I think are on our resource list. Chris mentioned a book coming out. There are several articles that talk about specific lesson plans. So I would say one, start small and trying to take a few lessons here and there and put them into whatever courses they're teaching, and trying to understand the main points of the lesson and drawing those out with students. I also think right now we're in a time where a lot of educational entities at all levels are looking at issues surrounding DEI and other equity issues, and statistics offers a way to sort of get to know your community. And one can look at your community through data. And there are ways that we can think of. I think we want to just think of anything we're bringing into the classroom. Is there a data argument for it? And if you think that way, then in any subject or in any place, you can think of, okay, well, what are the questions we're trying to answer? And then how can the data be brought in? So I think for teachers that are by themselves at their high schools and trying to do this, they need resources. And I think the ASA website offers a lot of those. And you're certainly welcome to contact us as well. And we'll be happy to give you this. The GAZE 2 report, to read that and really implement, you can implement those exact lessons in your classroom and use that framework. And then talk to other teachers in your district or in your school to see if you can get collaborative lessons across different subjects that are data centered.
Thanks, Anna. Chris, would you like to?
Yeah, I would like to make one comment. I think one of the big challenges that for teachers when they're first asked to teach statistics, and this is not something they've really thought about before, is the fact that most of our teachers have been trained as math teachers. And so when they think about teaching statistics, they think about teaching it from a mathematical perspective. They think about it as probability. They think about it as counting rules. They think about it as more formula driven. So I think one of the challenges is to help teachers understand this difference between mathematical thinking and statistical thinking. And once you can sort of make that leap, teachers can really start to grasp and enjoy the statistics standards. And one of the things that I think can help them with this are the mathematical practices. And if you look at the SET document, the Statistical Education of Teachers, there's a chapter devoted in the SET document to looking at the mathematical practices, the 8 practices through a statistical lens. And we found in our professional development that this has really helped teachers a lot to think about how to deliver the statistics curriculum that we hope they will deliver in their classroom.
Thank you. There are a number of questions related to integrating data science into high school curriculum. The next question is, if a school is going to offer both a statistics class and a data science class, who are the target students for each class?
Well, I guess in my experience is we kind of see a data science class as being a precursor. I mean, if there's only just one, if you're offering both, I mean, I think that'd be a tough decision, and it would depend a lot on what you meant by a statistics class. I mean, my own view of statistics is if it's done right, it would look very much like a data science course, but that's often not the case. And I'd say that knowing that I'm propagating one particular view of data science, which is that it's, especially at the K-12 level, that its primary goal is to teach students to make sense of data and to help them see how data can illuminate phenomenon in the world. You know, so it's about that aspect, and there are other aspects. So I would hope that this is kind of a false dichotomy, but what I think all of us are advocating for is not to think in terms of the course, but to think of terms of the curriculum, and really use this as an opportunity to advocate to our policymakers that we need to take this seriously from the very beginning and build in a serious sort of way, so that students can go to enter the university and will have, in any state, and will have a very sound background in data acumen. And I'd just like, you know, to say that the time is now. I mean, I think one advantage we had when we last tried this in the 80s and 90s is now that we have this huge cadre of AP stats teachers who know the subject so well now that they have their own visions of what can be done, and that knowledge is coupled with what high school students can do and what they need. And I think, you know, that's part of the secret sauce that we didn't have before. So I think, you know, we have the potential to really do some big, important changes now.
Thanks, Rob. So what skills would a teacher need to bring to a data science class versus an AP class? First semester, parentheses, first semester algebra-based stats class, parentheses.
Chris, do you want to take this one? This is related to AP, or do you want me to attempt to answer this one?
First, and then I can follow up.
Okay, so I think the skills are what we've been talking about all along, which are a mix of computational thinking skills and computation and statistical skills. To really sort of do it right, one needs both. And as Rob just mentioned, it's like we have basically an army of wonderful high-level AP statistics teachers. That's just they're such an asset, and helping, you know, and having them transition to thinking a little more broadly about data, and thinking about data in a more data science perspective, where we use computational tools as a means to analyze those data, or the data, then opens up sort of what we look for skills in teachers at that point.
So I'll maybe follow up a little bit. I guess the question of a data science course versus, let's say, an AP statistics course, what are the skills that are different? As many of you on this call probably know, AP statistics is very dear to me. And the course has been around since the first exam was given in 1997. And so I think it's important to think about when that course was developed and the curriculum that was behind that course at that time, and to realize, of course, things have evolved since then to this point now. Um, I know several people have asked the question, is there a foreseeable change in the AP statistics curriculum to maybe reflect more data science concepts? Um, my understanding is there's no immediate plan to change the current AP statistics curriculum. And I would doubt very seriously that there would be, given that the College Board program just put quite a bit of resources into developing teacher resource materials for AP statistics in its current format. One thing we have to remember is that the way these courses are developed from a College Board perspective is, are they going to be accepted by universities and colleges for their equivalent course? And I think AP statistics has always kind of held this unique place in the AP program where I don't think we can say there is one standard intro statistics course at colleges and universities, unlike, let's say, calculus, or maybe unlike chemistry or biology or some of the other AP courses. So when the course was developed in 1997, a lot of, let's say, traditional inference procedures were placed in that course. And people often ask, why so many inference procedures? We'll never cover that many in an intro college course. Well, that's because you're trying to cover all your bases of the particular course that a college might want with certain inference cases, for example. So one of the things that motivates an AP course changing is what are most colleges and universities accepting? And so now we're in a situation, from what I can see, where most colleges are still probably offering what we think of as the intro course equivalent to AP Stat. But more and more colleges and universities now are starting to develop what they call an Intro to Data Science course. So, well, the AP Stat course, people argue, needs to change. It needs to evolve to that data science course. Well, I guess the question I raise is there a standard Intro to Data Science course now at the college and intro level? Now, I don't see that College Board is going to make any changes until they start to see that there is such a course. So with all of that said, what I would like to see is, even though the curriculum itself that's going to be tested on the exam may not change in the AP statistics course, that doesn't mean that as an AP statistics teacher, you can't bring in data science concepts. For example, bringing in more multivariate thinking, then that's very easy to do. Then maybe what's on the actual curriculum guideline. Bringing in working with non-traditional data, bringing in working with large data sets, bringing in the questioning, and go beyond maybe the calculator. Now, I know technology can be an equity issue, and I've always understood that part of the reason the calculator is still used in AP Stat is the equity issue. And I do understand well, because there's schools in my state that don't even have the broadband to use internet. But hopefully, if you do have at least some internet access, then there are great applets now that are open source. And we've listed some things on the resource sheet that you could utilize. So you can bring in more computing and sort of bring in these data science concepts, even though the curriculum might not change. So I guess from my perspective, I would like to think that they're not two separate courses, that it's the same course. It's just that from an instruction perspective, you may need to enhance the curriculum that you're trying to prepare your students to take an exam for. But I think enhancing with those data science skills is going to even better prepare your students for what they might see on the high stakes assessment that they have. So I probably was long-winded on that answer, but maybe that helps.
That was great, Chris. In terms of developing computational fluency, an attendee asks, what data science software, languages, tools do K-12 students have the ability and access to use?
Yeah, so again, I mean, I don't know if there are any experts in this yet that really understand how to, our colleague Amelia McNamara calls it bridging the gap between tools for learning and tools for doing. But I'll mention, for example, that CODAP out of the Concord Consortium, which is another thing we should add to the resource list, and I'll put something in the chat thing right now, is one open source tool that they can use. Like I said, in IDS, we've been using R through RStudio with great success. It's not inexpensive. I mean, the educational use is free to some extent, but it does run on a server, and servers aren't cheap. If you do use the RStudio, you'd have to talk to them. I don't quite know what their fee structure is right now. If you have the capability in a classroom of downloading software onto the desktops, then RStudio is free, and R is free, but maintaining a set of desktops is a heavy burden. So there are issues to using the technology that that we haven't really worked out. I think our school system just hasn't yet really come to terms that we're living in a computational internet age, and where our classrooms, as Chris points out, are still kind of woefully underprepared or unprepared for providing the resources necessary for our students to move into this age. But I think, as professionals, we can kind of hold up a standard and keep demanding that standard be met, and advocating for greater internet connections within classrooms and universal access to computational software and mobile devices. I'll just add one interesting anecdote. I mean, when our IDS project was part of an NSF grant that began, I think in 2013 or 14, and it was using mobile devices to collect data. And a big part of the grant was to buy mobile devices for all of the students in the high schools. And at the time, I think maybe 50% of the students had their own mobile device. And so we were buying, phones for the other 50%. And the last time we did the survey to see what percentage of the students in Los Angeles Unified School District had mobile devices, and Los Angeles Unified School District, I think 80% of the students are below the poverty line. That was about 3 or 4 years ago. And I think 98% had mobile devices. What they did not all have at home was internet connections. So they relied on the school for connection to internet. But pretty much all of our students now are walking around with little mini computers that can collect and analyze data in their hands. We have to help them learn to use that tool.
Thank you, Rob. Next question is related to teaching data acumen. The question is there a place within K-12 that is a nice entry point into the iterative process of data science? And is there a place where we want to avoid getting boggled down in the messy and frustrating details of raw data at the K-12 level?
I can start us off on this one. So I think the place to start is kindergarten. So I think, and I firmly believe this, I think I've said it a couple of times already, that it needs to start early. And the messiness obviously can't be incredibly complex at kindergarten, but it's okay to have messiness. So for example, one of the Gaze 2 examples that Chris mentioned about the ladybugs, taking pictures of ladybugs and then looking at them has in some ways some measurement issues there, because you can't tell how many dots are on these actual ladybugs. right? So there are already some questions about measurement issues, and we could think of that in terms of messy, or you can think of students not answering certain questions on surveys and having missing values, and what do you do with missingness? And these are all types of questions that you can tackle early on, and needing to explain why you might omit a certain observation, and what the argument for that is. These are things that can be done really early. So I think when we are talking about sort of messiness at the higher level and data wrangling higher level, one of the nice things that happened about 8-9 years ago was the data.gov website went up, right? And this offers a plethora of raw data from all areas of government and all subjects. Now, if anyone's gone on there, if you kind of search by a subject, you think, oh, this is going to be great for my class or whatnot, and then you kind of look at it and the data sets are completely raw, and so it takes a while to kind of go through them. And I think as one does this, you gain more experience as how far you can push your students in the messiness. So maybe the first time you do something, you actually give them a clean, the cleaned one that you've already worked on. Then the next time you take it a step back of what you did and give them one that's a little more messy, but it's not quite the original raw one. And then you slowly back up. And so I've done this a couple times with the data.gov website or data sets. And, I'm now at a point where some of the data sets that I've used several times, that I can give it to them raw, because I know in my head the steps that I've done to clean it. And so I can scaffold students if they get stuck. Now, that's not doing this in a complete, genuine process of data science, right? In a data science process, they start with the raw and you have no idea what you're going to get. But in terms of an instructional scaffolding to get to that point, I felt that works really, really nicely. And then slowly you're getting to a point where you really can just download the raw and then let them clean it on their own. I hope that helps. I'm not sure if I answered it perfectly, but.
That was a good answer. And what I'd like to add, I guess, is, so again, this is another example of how thinking K-12 really changes our perspective. We don't have to think of what week do I teach data wrangling. It's something, learning to clean data is something that's going to happen through, gradually throughout their time through K-12. I do want to push back against the notion that it's somehow antagonistic to the primary goal of learning to reason with data. I think data cleaning is a modeling process. It's part of statistical modeling. It's part of the statistical investigation process. So it's really at the very heart of learning to reason with data. And I'll just give one quick example. Some of our UCLA undergraduates for the last couple of years have been cleaning the Census at School data set. So Census at School is I think it's K through 12, but it's at least 6 through 12. Students can go and enter a survey that asks them many questions, and then teachers can access a random sample of that survey of data from all over the world. So we've been helping the ASA clean the US data set. And one of the things they do is they make a plot of height versus arm span, wingspan, if you will. And when you look at the raw data, this plot has a dot at every single pixel on the graph. You're asking 6th graders to measure their height and their arm span, and you get every possible combination of values. And so learning to clean that data set requires bringing in contextual knowledge about how people are shaped, thinking like a detective in terms of what type of mistakes happen in the measurement process, especially if you're a 6th grader. It's a modeling activity, and it's far from trivial. And so I know there are people who ask this question didn't intend it this way, but I always kind of react that there seems to be something to kind of marginalize data cleaning as I think it's the word cleaning. No one wants to clean their room, and no one wants to make their bed, but it's actually a very creative part of the process.
Do you have
Can I just add one more thing, Piano? So
Sure.
as we were mentioning earlier too, in the context of data science, understanding data provenance has become even more important. So this process of cleaning is usually where as a statistician, you understand the provenance because you're sort of questioning that data set, making new variables, defining new things, looking at, omitting certain observations, understanding missingness, all of that is in that understanding data provenance. So I think as statisticians, oftentimes we take that for granted, and it's actually where we spend a lot of time, like most of the time on projects. So any of us who have worked with large data sets before, if you've done, if you've worked with large data sets before, 50% of the project is cleaning your data usually, if not more. And oftentimes you go back to clean it more, and you go back to define new variables, and you code up new things. So that gets skirted over a lot when we teach in K-16, even, and specific, definitely in K-12, but even at the college level. And so I think in the era of data science, let's say, that process becomes incredibly important. So we don't get into a tendency where we just put a visual up, and then we just ask, oh, well, what's this visual? And then we make assumptions about things without having checked the provenance of the data set, and where did it come from? What were the origins? How was it collected? All this kind of information that we think of as in that cleaning. So in the GAZE investigative process, let's say, the second component of collecting and considering data has a huge role. And I think for most statisticians, it's always had a huge role, but in our curriculum, we have not given it a huge role. And I think now we're in a situation where we need to give it much more of a role, particularly to understand problems that we're seeing on the output, like biases and algorithmic issues and whatnot. That data provenance in that component becomes more important than ever.
Well, with that, that was the end of our Q&A session. And so time went by very quickly. In the less than 2-hour session, our panelists couldn't address all aspects regarding teaching stats and data science education in grades K-12. But we hope that you will find the experiences, resources, and opinions shared by our panelists today will be helpful in your work. And we also hope that there will be more platforms and channels opening up for discussing teaching stats and data science in grades K-12. So on behalf of NEAS, many thanks to our panelists for taking their time out to join us to make the debate possible today. And we also would like to thank our attendees. Please fill out the survey after the event. We, as organizers, would like to know what you think of today's event. Thank you very much. Have a great day.